All right, AP, let's get to plugging and chugging. So we need those calculators. We're going to talk about our good friend, Mr. Avogadro. Avogadro and the mole. So first thing I'd like you to do is AP Daily 1.1. These are the 3 learning objectives that AP expects you to be able to master in this topic. A key thing that is coming our way is the new unit for molar mass. So you have this equation that's right here, moles over molar mass. So notice right here where it says little m is mass. Remember, mass is grams. Big M, molar mass, and molar mass is this new unit, grams over mole. So what happens when you take the grams over moles, it's called the reciprocal. Your grams cancel, and what are you left with is moles. And we call that little n, the abbreviation for moles. Mole can be MOL. You could put MOLE. Either one is fine. The other key thing is Avogadro. Avogadro's number, 6.022. We're used to 6.02 times 10 to the 23rd that we used in CP and honors. But 6.02 to the negative 23rd. So take a minute to read, annotate, and then come back and let's start talking about some moles. Moles links chemistry to about every topic that we're about to do in this class. Okay, so we're going to talk about some gas laws, we're going to talk about kinetics and thermal and electrochem. Moles is the center of everything. So it's the standard number of particles, and we've talked about particles before, where atoms, ions, molecules, formula units. The reason for the different units is who is the chemical. So if you have an atom, it would be like sodium, or if you have an ion, you would literally see the charge on paper. A molecule would be a molecular compound, and formula units, we would use ionic compounds, as you see right here in the box. So a mole of anything is Avogadro's number in whatever chemical that you're looking at. So we need to get used to this number for Avogadro, 6.022. So if I have an atom, but not diatomic, okay, so I would use an element for atoms. For diatomics, I would use molecules, so like Cl2O2. A molecular compound like sugar, CO2, I would use molecules, so like C6H12O6. Heck, even water, CO2, any type of nonmetals. And formula units, metals with nonmetals or polyatomics. Then we use the word formula units. You may abbreviate formula units, FOR, and then the word units. Let's not try to abbreviate the word formula any shorter than that, okay? And you know what I mean. So a formula unit would be like salt, maybe some sodium nitrate, anything with a metal and a nonmetal or polyatomic. We talked about in the last video the new unit for molar mass, and you can abbreviate molar mass, MM, grams per mole. Now we're used to molar mass being just grams by adding up the elements on the periodic table. Well, what happens if it's not adding the elements? What if you have an unknown and they want the molar mass? So now we have a new unit. And I believe this is also on your equation sheet. So example number 1, let's get those calculators. I have an ionic compound, 47.4 grams. So I know my grams. And I know my moles. What is the formula mass? Well, formula mass is, formula means ionic compound. So I want to know the formula mass, aka the molar mass, and I got the grams and I got the moles, okay? So instead of doing a know and a don't know chart, like if you have a worksheet or a test, circle the information that you know and label it. So I got my mass, so molar mass, okay, or you can call it formula mass since they called it formula mass. I got the grams, which is grams per mole. Always list some type of equation. And then 47.4 grams over 1.185 moles. It's a simple calculation. So if I don't know who's in the compound, I can solve for molar mass by taking the grams, divide by the moles. So when we plug this in, looks like we're going to keep 3 sig figs. So 47.4 divided 1.185. And always check my work, ladies and gentlemen. Always check my calculations. 40.0 and then grams per mole. And that's it. Okay, so that's another way of finding molar mass, formula mass, molecular mass, if you don't know who the chemicals are in that formula. Let's try another one. If I have 256 grams of a monoatomic, so that means it's just an element. Monoatomic meaning one and then an element. So I'm not talking about a diatomic. And it's known to be 8.26 moles of that element. What element am I talking about? Well, I need to do molar mass. So molar mass is the grams over the moles. And I have 256 grams over 8.26 moles. And when I plug that in, 3 sig figs, I'm going to get 31.0 grams per mole. So I'm going to box it, but I'm not done yet because I also said what element. So now it's called look at the periodic table. And whose mass is closest to 31? So if I go to the periodic table, I see that looks like the element phosphorus. You can write the name or you can write the symbol. Okay? Unless AP says what is the name of the element, a symbol is just fine. Because we had to calculate and label it, make sure you put the element in the box too. Now let's do a little bit of stoichiometry, or actually conversions, not really stoich yet. How many carbon atoms? So that's what I want to find, okay? And I have 16 grams of glucose. So I have a molecule and I'm going to an element. Now, for some of these homework questions, as you notice right here in blue, I put the answer on there because I'm going to help you set it up, but you're going to solve for it. So that way, check your answer with what I have that's listed in the blue. All right, so we have 16 grams of glucose, C6H12O6. Now, anytime you have grams, let's look at our roadmap. We're going to go grams, and we're going to go to moles, okay? And then once we go grams to moles, remember, we still got glucose, C6H12O6. Then I need to get to molecules, and there is no abbreviation for molecules. Once I get to molecules, then I can get to carbon. So I'm looking at 3 steps here. All right, so number 1, grams. And I got to put the chemical everywhere because I'm eventually going to change the chemical. And 1 mole of that chemical. Now what do I need here? And I'm going to list it for you in a different color. I need molar mass. So we're going to have to show some work down here for molar mass. So carbon, I have 6. And hydrogen, I have 12. And oxygen, I have 6. So this molar mass that you solve for, that grams, that's going to be listed down here. Now remember, molar mass always equals 1 mole. So on top, I'm going to have 1 mole. So you're going to finish this part of the calculation. All I did was get rid of grams. So now it's called go moles to molecules. Well, who do I need? I need Avogadro. And we know that 1 mole always equals Avogadro's number. Okay? It's just what the units are depend on that chemical. So now I have 1 mole, and I haven't gotten rid of the chemical yet. And then Avogadro, we have our 4 sig fig number times 10 to the 23rd. And because this is a molecule, I'm going to put the word molecule. You would think Avogadro would like to put an abbreviation for the word molecule instead of mole, but it's his number and we got to play by the rules. So bye-bye moles, and there's Avogadro. Now it's called get rid of the chemical now. So in this, I like to call count. Count what you see. So in this whole molecule, so I'm going to list 1 molecule of this glucose. and I want carbon atoms. Well, how many carbon atoms do you see? Well, I look at the formula and I see 6. And because I want atoms, because it's an element, now I have carbon. Not only did I get rid of the molecule, but I got rid of the chemical. So how do you plug this in the calculator? Okay, so let's do a little highlighting here. You're going to take your 16 and obviously times 1, multiply by Avogadro times 6. So you're going to multiply that all in. Don't worry about sig figs and rounding. Don't worry about none of that. Hit your equal sign, and then your molar mass at the bottom, which if we did this molar mass correctly, should be around 180.16. Check my work. And then what you're going to do is you're going to divide, and I'm just going to write it in red, but don't list it in the work, and then divide by that 180. Okay? And if we do this correctly, we're going to box that final answer and hopefully get around 3.21 to the 23rd. Just a quick reminder about scientific notation. When you plug this in the calculator, 6.022, that times 10, that's your E button. So whatever button is your E button, and then you're going to type in 23. Okay? So make sure you know which E button is your correct E button. Okay? So double check that you get the answer 3.21 to the 23rd. Let's try another sample. Like I said, I'm going to set them up with you, and then you guys are going to calculate. If I have aluminum sulfite, okay, and it has a known atoms of aluminum, what's the mass of the entire aluminum sulfite in grams? Well, if we do this right, we should get about 111 grams. So basically, it's like number 3, but going backwards. Okay? So I have 4.55 times 10 to the 23rd atoms of aluminum. Okay? And now, with those atoms of aluminum, I'm going to count what I see. Well, the problem is I don't even have a formula for aluminum sulfite. So I need to remember this is an ionic compound. So I got to do a little crisscross. Aluminum is +3. Sulfite is a polyatomic. SO3 -2. So do a little crisscross applesauce, which means I need some parentheses. Al2, parentheses, SO3, parentheses 3. So Al2, just checking my work, SO3, parentheses 3. All right, so in here I have atoms of aluminum. And now I'm getting to this compound, which because it's ionic, it's going to be formula units of Al2, SO3, 3. Okay? So this is where you count what you see. I see 2 aluminums in that whole compound. So in the atoms, so count how many atoms in that compound. Okay? So bye-bye atoms and bye-bye aluminum. So now I got my formula units. As I said, it's like going backwards. So now let's get rid of formula units. So Al2, SO3, and then I'm going to get to moles. And because the chemical isn't changing any further, you don't have to list the chemical anymore. If you don't want to list it right here, that's fine. But I do need Avogadro. 6.022 times 10 to the 23rd. And remember, Avogadros equals 1 mole. So 1 mole on top. Bye-bye formula units. And as I said, I'm not trying to get rid of the chemical. I'm just trying to get to mass, which means I want grams. And then 1 mole. And then I need molar mass. So we got some work to do. So I got aluminum, 2, sulfur, with that parentheses is 3, and oxygen is 9. So calculate that molar mass, and if we do this correctly, we should get 111 grams. How many nitrogen atoms are there in 45.8 grams of ammonium nitrate? Well, I see words, which means it looks like I'm going to need some formulas. So ammonium is a polyatomic, NH4 plus. Nitride is N, and nitrogen is -3. Because that IDE ending, that means it's coming from an element that's an ion. So do a little crisscross, and I'm going to need to put that 3 with parentheses. So NH4, 3, and then N on the outside. So it's basically what you just did on number 3. I'm just going now to nitrogen. Okay, so let's set it up. So I have 45.8 grams of NH4, parentheses, 3. And you know what we should be doing now. So I got grams of NH4, 3, and N. And I'm going to get to moles. So I'm going to need molar mass. So let's make sure we count it correctly. For my nitrogens, I not only have 3 here, but I have this nitrogen right there. So I got 4 nitrogens. And for hydrogen, I have 12. Okay, so find your molar mass. And then I got to get rid of the moles. And because nitrogen, hydrogen, and nitrogen are all nonmetals, this is a molecule. Even though you did a little crisscross, you got to remember the definition of a molecule is nonmetals with nonmetals. So I'm going to use my 1 mole and my Avogadro's number. Now, I haven't gotten rid of the chemical yet. Okay, so technically, this part and this part and this part, if you don't want to write the formula, that's okay, because you haven't gotten rid of it yet. But here's where now we're going to get rid of it. I'm now in this whole molecule of this NH4. So bye-bye grams, bye-bye moles, and here goes bye-bye molecule, but now bye-bye chemical. I want atoms of nitrogen. And remember our molar mass, we had 4 nitrogen, and count what you see, 4 atoms. Okay, so one more time when you plug this in, you're going to plug in the 45 times Avogadro times 4, and then you're going to divide by that molar mass. And if we do this correct, 1.62 times 10 to the 24th. Let me go back to number 4. We didn't talk about how to plug it in. With number 4, you're going to take your 4.55 and you're going to multiply by molar mass. But now in this case, you have 2 numbers to divide. So once you take your 4.55 to the 23rd, don't forget your E button right there, times that molar mass, hit your equal sign on your calculator. And then hit divide 2, hit equal, and then divide Avogadro's. Don't forget your E button. Okay? So if you're struggling on how to plug it in, let me know so I can show you in class. All right, number 6. How many grams of oxygen are present in 156.8 grams of calcium phosphate? Well, I'm already seeing a name, which means I need to get this into formulas. So calcium is a metal, so +2, phosphate, polyatomic, -3. So calcium, Ca, and phosphate is PO4. So when I do my crisscross, my 3 and my PO4 with the 2 on the outside. So we're going to start with that 156.8 grams of that calcium phosphate. And the question is, where should I go? Well, anytime I got grams, let's go to moles. Now, not trying to get rid of the chemical yet, I'm just trying to get rid of the grams. So mole on top, 1 mole, which you know, we need some molar mass. So calcium 3, phosphorus, I have 3, and oxygen, I'm going to have 12. So multiply, oh, I apologize, I even saw a little boo-boo before I began. Should be a 2 right there. See, you're probably thinking, Rodriguez, All right, so that 2, and I got to fix my oxygen too. All right, a little early for me. All right, so 3, 2, and 8. So if we do this right, this molar mass should be around 310. All right, so calcium, and make sure you guys are showing your work. So the purpose of these videos, ladies and gentlemen, is to show you the steps. But I can't show you everything because how will I know if you understand yourself without you trying? Okay? So now I want to get to grams. I don't want to get to atoms. Okay? So I don't want to use Avogadro. So there is a step on your conversion map where you can go moles of the compound and get to moles of the element. And it's the same thing, count what you see. So in that whole compound, because this is where I'm going to get rid of the compound, how many oxygens do I see? Well, remember my molar mass, I had 8. I see 8 moles of oxygen. So bye-bye not only mole, actually you don't have to get rid of the mole. I wasn't trying to get rid of the mole, I was trying to get rid of the chemical. And now this is when I actually get rid of the mole. In a mole of oxygen. Now this is where it gets tricky for students because they're starting to think diatomic oxygen, but I don't have diatomic oxygen. In 1 oxygen, what is the mass for 1 oxygen? Well, it's 16, not 32. So when you plug this in the calculator, you're going to plug in that 156 times 8 times 16. And then you're going to divide by your molar mass. And if we do this right with correct sig figs, 64.71. Now remember, when you get to these moles, ladies and gentlemen, this stuff right here, this is not counted as sig figs. Because AP has a rule, we don't do 1 sig fig on the AP test. So you should get 4 sig figs in the end. Box that beautiful answer. Now let's try an ions one. What if I want to get to gallium ions? Nothing tricky about it, but I have gallium sulfate, so we need to write a formula. So gallium, and if it doesn't tell you the Roman numeral, which it should, okay, which I'm going to fix my notes right now and say Roman numeral 3 plus 3, and then sulfate, SO4, negative 2. Little crisscross, SO4, parentheses 3. And double checking my work here. Okay, all right. So I'm going to start with my 65.8 grams. And what do we need first? And hopefully you guessed molar mass. So that's why everything goes through moles. So let's count it up. We have gallium, we have 2, sulfur and 3, oxygen 12. And when you do the molar mass for that, if we do this right, it should be around 427. So you do it and prove me correct. And 1 mole on top. So I can't get rid of the chemical yet because I got to get to formula units first. So in 1 mole of this compound, and I know it gets kind of tedious writing the compound all over the place, but you're showing AP your thought process. It's not about trying to find the shorthand. It's about proving to AP that you know what you're talking about. Okay, so bye-bye grams. You're going to put your molar mass number right there. Bye-bye mole. There's your formula units. And now count what you see. So I apologize, I'm cramming it in here. In that whole compound, formula unit of that Ga2 SO4 3, how many galliums do you see? Well, I see 2 galliums. But notice I said ions. Okay, remember right there, gallium has a +3 ion. So I have to not only put gallium, but I have to put a charge on it because I want ions, not atoms. So you have to go back to the original formula. What did you put on that actual gallium? So 2 ions of gallium +3, and then bye-bye formula unit, by chemical. So when you plug this in, we're going to take that 65 times Avogadro times 2, and then we're going to divide by our molar mass. And if we do this correctly, we should get 1.83 to the 23rd. Okay? So ladies and gentlemen, make sure you're showing all your work for that credit, and make sure also either box your final answers or highlight them, but please make sure every answer, number, unit, chemical. Okay, get used to that setup. I'll see you on the next one.